Hi, my name is Jason Huber. I'm the Director of Solutions Engineering here at Akkio, and I run both the Solutions Engineering team as well as the Customer Success team. What we're here to do today is talk about predictive AI in practice, identifying problems before they happen. We're going to look at employee attrition today, but let's see if we can apply it to some of your use cases as well. What we're looking at here is we have a lot of data in our enterprise. We've been collecting data for a long time, and in the past, down here, what we'd use that data for is to see what happened. Look in the past and say, oh geez, this occurred, what could we have done differently? That sort of thing. We have tons of data, we've been collecting it for a long time, and now the power of that data is really predicting the future, seeing what sort of outcomes we can get to predict a business outcome that's positive for the business. Reducing employee attrition, reducing customer churn, maybe inventory management, procurement management, anything like that. Some of us might be thinking of the stock market, maybe not the best use case, but if you have the right data set, of course, machine learning can do that too. Now, a few things that we can predict, you can see on the screen. Employee attrition is what we're looking at today, that big green square in the middle there. But you can also look at lead scoring. If you're in a sales organization, you might want to look at those leads coming in and say, here's the persona that typically buys our product or is successful with our product, and let's see what the leads coming in and how they match up with that. Akkio can make that happen very easily. We can also do sales forecasting. We can detect fraud. We can look at credit card transactions, bank transactions, and see what sort of transactions are typical, train the model, and then put any new transactions through that pipeline and say, ooh, flag the fraudulent or suspected fraudulent transactions for further review. Customer churn, I already mentioned. Supply chain disruptions as well. If you have your supply chain, here's how many things that were sold, or maybe we're shipping something from China to the United States, and we've been affected in the past by weather, by climate changes, anything like that, maybe patterns that occurred during different parts of the year. We can forecast as well, not just predict, but also forecast how long things may take to ship or what the cost might be depending on what time you ship those items. So all sorts of different ideas. While we go through this, think about a use case for your environment and how you have data now, maybe what data you might need and where you might get that, and what use cases you might apply that to. So we're focused on employee attrition. Some of the things that causes is increased hiring costs. We know that it costs about $30,000 to $60,000 to train an employee, depending on what industry you're in, of course. But you don't want to lose those employees after they've been here for a period of time, of course, because decreased employee loyalty. They see some of the people that have been here for a while leaving, that sort of thing. Less skilled workers, you have to retrain them. Employment gaps, maybe you can't find somebody to fill that position. Decreased productivity, low morale, and inconsistent processes and systems can all occur. So we want to maintain or keep our employees as long as we can. That's the retention of the 3 R's. So what can Akkio do about that? Well, we take the data that you already have, we train a model, and then we use that to predict, in this case, which employees that you have in your system might decide to leave the company and why. So we see the ones that are, in this case, let's say, at risk of leaving the company. We'll show you how we'll do that. Now, everybody that's watching this can accomplish this, I assure you. If you have the data and you know the outcome that you're looking for, have an idea of it, you can use Akkio to accomplish this. And let's talk a little bit about some of the other tools that you may have experienced or heard about in the past. I was a data scientist, and I used to write this in Python and Java. I used to build models all the time. And what would happen is we'd have somebody from the business come and say, hey, Jason, or data science team, we need to do this or that, right? We need to do some sort of business outcome. And we would take a look at your data and say, okay, well, you have the data for it. Let's see what we can do. And we'd move on and say, here's the project plan. That would take a few weeks just to come up with looking at the data, seeing what's in the data, maybe fixing the data, and then say, okay, we can start to build a model. Then I start to build a model. It takes another few weeks, right? It takes some time. We're looking at the data, seeing what the trends are in the data, analyzing that sort of thing. Once I've built the model, then I come back to you and say, do you like this model? If you want any changes to it, it takes me time to rebuild the model because I literally have to change the code, change the outputs, make sure it matches what you told me, and then we talk about it in a meeting. So weeks have gone by at least. Then finally, I need to get that model into production. When I get it into production, that means I need to give you access to it. The model is a bit of Python or Java code that's running on my laptop or running on one of our dev environments somewhere. You need access to that and the ability to call and say, well, these 1,000 employees, which ones are likely to be to attrit? And so I need to build an interface for you to do that. And that I would probably pass off to another team, depending on what organization I was at in my past. And they would say, we'll get that done in a few weeks. So you're looking at 6, 8, 12 weeks to get a model from conception into production. That's being conservative. So what changed was we came up with these platforms, right? There's a whole bunch of platforms out there. I used to work for one. and there's a bunch of others. The problem with the platforms, they're still designed for people that are writing that Python code or the Jupyter notebooks, that sort of thing. So they're very complex interfaces. They allow you to do a lot of things, turn a lot of dials, twist a lot of knobs, that sort of thing, but they're very complex. Akkio, on the other hand, still gives you the insights into your models, but it's fast and intuitive. Again, everybody on this call can accomplish it. I'm going to accomplish a model in production, as we call it. I'll show you that in the next 15 minutes here or less. A lot of the tools were built for data scientists, like I just described. We were built for anyone who works with data. So we don't expect you to have a data science background. We're going to present you with some of the data science things like an F1 score, recall, precision analysis, all that sort of thing. But you don't have to understand them. You can always ask somebody, or we're going to give you an explanation on the screen about what those mean. We'll give you insights within the first few minutes of you uploading your data about your data. When I built that model in that scenario I just described, that was for one project. So I took a number of weeks to build it for one project, and I was working pretty much full time on it. With Akkio, you'll see in the next few minutes, we're going to do that same sort of thing together all at once. And the tools were expensive. So these tools start out at tens of thousands of dollars just to get started, at least, easily into hundreds of thousands of dollars. And that's just not where Akkio's at, right? When you talk to our team, we're far more cost effective than that. Okay, so how does Akkio actually do it? You can do machine learning in a variety of ways. You could hire a data scientist. You could have a team to do it. How does Akkio do it different? Well, we start with your raw data, and then we do data prep. This is where I would spend 80% of my time as a data scientist. 80% of my time. No joke, just about any data scientist you talk to would agree with that. A high amount of our time is spent on data preparation, getting it ready just to model. Filling in gaps, filling in nulls, holes, maybe some feature engineering, that sort of thing I would do. We can do that right in the platform. I'll show you that. Then I do some visualizations. I want to look at the data. I want to see where the spread of these features are, the columns, where the values lie. I want to chart each one of them out and see if I have any outliers, any inliers, anything that might be causing a problem with my data or skewing the outcome. I need to visualize that and see it, and we can do that quickly with Akkio. Honestly, as soon as you upload it, we'll do that for you. You can just scroll through the columns. That's how quick it is. Then we want to do machine learning. That's where we take the data after it's been prepared, after we've done some analysis, we've learned some things about it. We're confident of what it can do, and we take it and we apply it to all of the models in our system. Now we apply the 80-20 rule. We'll take 80% of the data you give us, we'll train each one of our models, and then we'll take 20% that we withheld, we'll act like we don't know the outcome you're looking for, and then we'll test that data against the model we trained, the models we trained. Then we give you the best model, and we tell you which model that is. So 80-20 rule, very common in data science. We do it automatically for you. You just wait for it to happen, and I'll show you that here in the next few minutes. Then we deploy it. Again, in that scenario I described before, I'd build the model, take me a number of weeks, we'd iterate through it, we'd get it the way we want it. Then I had to give it to somebody to build an API or a web interface or something for you to access that model. With Akkio, we click a button, you get a web interface to access it today. We also give you an API to access it today if you want to hand it off to your developers. There's always a lot more you can do with it, but you can quickly give them either an API to access that model, or you can access it via the website, upload a 1,000-row, 10,000-row spreadsheet and say, hey, here's all of my current employees. Tell me which ones are likely to attrit in this scenario that we're working with today. We'll give you that spreadsheet back within a number of minutes or less, and you'll see exactly how likely they are to attrit, to leave the company, and our confidence either way. So we get 3 values out of that. Are they likely to attrit or not? And our confidence, yes or no. So you can sort by that and then say, well, let's go after the top 10% because we don't want them to leave. Talk to the manager, see what we can do. Why are they unhappy? We'll help you with that. We'll also help you understand which features, which columns, which properties of that employee are likely to be contributing to them being unhappy, so you can go and see if you can address those directly across the organization. And then finally, monitoring. As you build this model today, like we are, it becomes stale, right? People leave for different reasons. As we see in the current climate, social climate, people are leaving companies for different reasons. We need to retrain that model, and we can do that quickly with Akkio. The final outcome that we want is insights and actionable predictions for the business. We want to have a business outcome. Today, we're talking about employee attrition. We want to retain those employees, identify the employees that are likely to leave, improve the culture, improve whatever it is that's causing them to look, employee satisfaction, that sort of thing. And you can apply that to a variety of different industries. So that's how Akkio does it, all in one platform. So here's a few scenarios that we run through. Alex was doing some search engine optimization, and he wanted to know what the impact was going to be, run some what-if analysis, that sort of thing. But wanted to see what his clients that he does SEO for why their articles were doing good and doing bad, so he could apply that across his entire client base. We took his data set, Google Analytics, essentially, and we could give him some insights in that and say, hey, here's what happened, here's what contributed to the average daily session count, the average session time, that sort of thing. And here are the fields that contributed to that for this article or this group of articles on this website. So we give them those insights quickly, and you kind of see that on the screen a little bit here. Of course, we've mocked up this data for him. How Christina can forecast support tickets. So again, not exactly her data. We don't want to show her data on the screen, but the idea here is that runs a call center, and Christina was worried about staffing. There's times that would come across where too much staff, so people would drive in and then have to be sent home, or be on the phone at home. Now they're all based in home these days, and then be told, oh, you're off for the day. That makes employees unhappy. They're planning for the day, and then they're told they don't have to work, so they kind of miss out on pay as well. If she can better staff or plan for staffing, her employees will be happier. So what we helped her do is say, well, here's your staffing from January to August, and then here's what you should be planning in the future. The other thing I'll point out here is that gray line, or that light blue line that's kind of shaded around the dotted line. That's showing our confidence interval. That's telling Christina how confident we are in that forecast in this case. Not just a prediction, but a forecast in the future. So she understands that come October, middle October, November, we probably need to retrain this data, and we can do that automatically as well. Okay. So finally, how Martin can predict which people will donate to a candidate. So Martin runs a campaign funding firm where they call you up and say, hey, do you want to donate to this candidate, that candidate? And it's interesting to find out with Martin that these are all real use cases, that there's very, very few people actually donate to a candidate. It's a sliver of people. And what we were able to do for Martin, along with everything else we've showed you, is also say, put these different individuals into buckets. We call that segments. Here are the ones that are likely and less likely, least likely to contribute. So you can kind of see the attributes of those individuals. In this case, we see job title student, marital status not married, a few other features, again, we've mocked up. But you can see we'll put them into buckets, and that way Martin knows, well, if the individual fits this kind of profile, they're more likely to contribute to a campaign or less likely, that sort of thing. So those are a few different scenarios. Let's see how Akkio accomplishes this. Again, you can do this in a variety of ways, but we make it easy. We make it so everybody watching this video can accomplish what we just talked about using the data that you already have access to. All right, let's switch to the product and see. So I jumped over to the data set that I uploaded, just like I told you before. Now to do this, I'll just click on the Akkio logo and show you. We hit Create New Flow, and we upload our data. Now these are the formats we upload today, but you'll see additional cubes connections being placed in here. So CSV, Excel, and you can see the others that are there. If you have something that you're interested in, can you pull in from this location or from that location, this data store? Let us know. It's something we can probably do. Just support@akkio.com. So I've already got mine built, so I'm just going to delete this flow. We'll go back to this one that I've already been working on. Now, all I've done so far is uploaded the data. There's only 1,400 rows in this data set, which isn't a ton of data. Don't forget, a very common misconception with data science, you need a ton of data, millions of rows. That's not the case. 1,400 rows might be a little too little of rows to work with a data set, but you can accomplish some things with only 1,400 rows and 35 columns as well. I say, as a general rule of thumb, start with the tens of thousands of rows, and let's see where it takes us. We'll know quickly, and you'll see this in a minute, whether that's enough data or not. And we'll see, in this case, actually a pretty good data set with only 1,400 rows. So take a look at what we did. We showed you a chart quickly. We did some exploratory data analysis on this. Age, I can see most of our ages go from 18 to 60. Makes sense, right? That makes sense. If I had somebody in here that was 120 years old, I might see that maybe there's a little typo when they were typing in data or something like that. I could quickly fix that. Attrition, yes or no, that's really what we're looking at. I see my split is 83% have not and 16% have. I can see the correlation to my daily rate. How much are they getting paid? I can see that spread, how it goes across, and I can see what job role contributes. So I can see the correlation between the different columns or fields or features in your data set just by a click of a button. Again, this processing before I started the video took a minute or two to do. That's all. And again, if I scroll to the right, we can see hourly rate, job involvement, that sort of thing. If there's anything funny in here, I might want to touch it. So I said I spent 80% of my time as a data scientist manipulating data, and it's true. How do we do that in Akkio. The first thing is data cleaning. I'm going to click on that button there. I'm going to zoom in just a little bit. We do a few things here. I know you can read them, so I'll let you read them, but I'll point out, we'll look at date columns. We'll replace nulls. We can place excess categories with other, that sort of thing. Anything that's unreadable, right? We'll fix that for you. Blank columns. A couple things that are a little more advanced, and we don't check them by default. We ask you to take a look at them, is flag outliers. And I know you can read what that means. Flag inliers, and we can also clamp outliers. So allow you to do some pretty advanced data cleansing just with a click of a button. I don't need to clean this data set, so I'm not going to make you wait through that. It takes a minute or two, but that's something you could accomplish with it. What I am going to do is use Chat Data Prep to manipulate what I have here a little bit. Now I've got some prepared, but I think one of the things, I'm just guessing here, I've worked with this data set a little bit, but I'm just guessing here, and I think that what might happen is something that might contribute to attrition is how many times they've changed jobs versus how long they've been in the workforce. So I'm going to paste an example here, add a column for average year of job change. You notice I'm not telling it to divide this column by that column or anything like that. I'm literally typing in, add a column for average year of job change. I'll hit preview and let's see it go. What we're doing behind the scenes is we're actually leveraging something you've heard of, ChatGPT, to take a look at this. We'd only send the metadata, the data about your data. We don't actually send your data anywhere else. And what that does is actually build some Python code for us and comes back and says, here's how you should manipulate that data. And what we do is then we'll turn that and we'll apply that to your data set on our side only. So the initial concern comes up, are you sending our data? Definitely not doing that. You see, here's average year of job change. It came up with a feature for me, or a field, a column for me. Said, do you want to preview it? Yeah, this looks good. We have some young people here that haven't changed jobs a whole lot, or maybe there's not data for it. That's good. So I'm going to apply transformation. So quickly, I did a feature engineering, created a new feature based on just something I was thinking out loud. Now, I know I also have some young people in here, and they kind of skew the data a little bit. If they're very young, I'm gonna say I don't really want to look at them because they're starting out in the company. We have a lot of intern type jobs, that sort of thing. So I'm going to eliminate those from the data set. I'm going to say remove all rows where age is less than 19. So no calculations there. I don't have to know any SQL. I'm literally just typing out sentences here and let it go. Okay. One other thing I'm noticing there is that if you look at the what do I want to say there? If you look at the actual business travel column, you see that it has a travel prefix. I'm just going to copy this that I've prepared already. Let me apply that transformation to remove everybody. It's going to remove 0.5% of the rows as well, if you notice that. If you look at that, it says travel before every single one of the rows in business travel. I don't really like that. I'd rather it just say rarely, frequently. That way reporting is easier in the future. So I'm going to say remove the travel underscore prefix from the values in business travel. Hit preview, and we'll go. So this is how we can manipulate the data very quickly. And again, a lot of this you could do in Excel, but we can also look for Six Sigma outliers. We can look for outliers in your data. Maybe not Six Sigma. That's a totally different thing. But we can also say, hey, give me the average education. Remove everybody that's below the average, above the average education, things like that, and it'll go through the entire data set. That takes a little bit more time to do in something like Excel or some other spreadsheet program. So as soon as we remove the travel prefix, we'll look at how we can actually visualize some of this data as well. Okay, there we go. I like that. So we've fixed that data. We'll apply the transform. Now, let's just take a look at exploring the data a little bit. I want to visualize this somewhat. Now I've manipulated, I've cleaned it up, I've manipulated a little bit. Let's explore the data just a little bit. If I come into Explore, just click this at the top, come into Explore. I can say this here. What are the key factors contributing to attrition? Just simple like that. Just type it in and see what it comes up with. Just exploring it, seeing what I think. And again, behind the scenes, you can tell down here we're using GPT-4, or we're using GPT-4 to do that. I can switch it to GPT-3 if I wanted to go a little bit faster because it's new and there's every once in a while a little bit of capacities issues with it, so we wait a little bit longer. But in the background, we're sending information about your data, not your data itself. Over there, it'll come back, tell us what to do with it, and then we apply that to your data. So we're just leveraging it for the information of what we should apply to your data set. So we see here the biggest things that are applying is distance from home. That makes sense, of course. Number of companies worked, I kind of suspected that. That's why I created that other field. Monthly rate, performance rating, hourly rate has a negative impact on whether they attrit or not. Percent salary hike has a negative impact. So we could look at that a little bit more. What is the percentage salary hike and what's its relation to it, that sort of thing. So if I come back and I take that a little bit further, I can say, how does distance from home contribute to attrition? And a quick cut, and we see that the chart is there. Looks like 24 miles from, yeah, that's a little distance. 13, 22, etc. That's how it contributes to their likelihood to attrition. Now, I could always sort this by distance from home if I wanted to, but it's interesting. 28 miles from home, they're less likely to attrit. That's interesting to me. Probably work from home. I'm not sure. I'm just guessing here, but 29's in there too. So it isn't a direct correlation. It isn't what I thought before. Let's do one more thing that's interesting. We can really stretch this a little bit. And now, because we know we can do what this is, first of all, let me save that one. I really like this one. So I'm going to save that one to charts. So it saves it over here for me. Go back to Chat Explorer. So I'm going to say, let me just scroll through that and show you a little bit better. But understand each prompt. Let me just create a new one here. There we go. So it says understand each prompt. You're in job role. You'll see I fill these in later with expertise and skills. You recently came across ChatGPT, which can answer anything you want, etc., etc. And we say understand each prompt and insert placeholders we think the user needs to specify columns. So here we go. There we go. Okay, and I just hit play. Just an interesting way. And this is something I would save, and I have saved it, so that I could use it later. Okay, and there we go. Here's its response. It says, as a company leader with expertise in data analysis, you can use the following detailed prompts to identify patterns and interesting. It tells you what insights you may want from the data. So analyze the connection between department and attrition to define certain departments have higher attrition rates than others. Let's just copy that. I'm just going to paste it in here and see if that's a good, I probably would reword that normally, but let's just see what it does. So I can actually ask Akkio about my data and say, hey, here's the data set. What should I be looking at? What things do you think are interesting? And then it gives me one. I copy and paste, say, okay, tell me about that. And here we go. Sure enough, ouch, research department. Ooh, wow, okay. So yeah, we probably need to dive into that a little bit. What's going on in R&D, right? Could have a manager, could have a problem with pay, could have a customer satisfaction, toxic employee, who knows? But maybe it's the location they're at. Maybe it's just that industry, and that's common across that industry. HR individuals would be able to identify that. So I can save that to charts as well. And if I go back to Chat Explorer, I can also share this. If I want to give this out and say, hey, allow public access to this, I can. And say, go ahead, and you can play with this as you see fit. So I can share that out and let you play with the data as well. So we've got the data the way we want it. We've manipulated a little bit. What do we do next? The real thing we wanted to get to was business outcomes. I said we spent 80% of our time doing what I just showed you, and I spent a few minutes doing it, but that would have taken me weeks in the past. And I'll be frank, my charts aren't that good, right? I'm not creating charts that look like that. I would rely on another tool completely to do that. As a data scientist, it would be kind of difficult, to be frank. Mine would be very ASCII level charts. We can also merge data and filter rows here as our prepare data step, but I'm going to jump to train model. Now, you see we could forecast. We talked about a use case before with Christina and the call center forecasting, how many people she should have on the phone. We can also detect anomalies. We're going to stick with predict for now. I want to predict attrition. A few things I can do here too is ignore fields. I know I don't want to look at their daily rate. There's a few things in here that just their monthly rate, their monthly income. Of course, that's related. That sort of thing. Okay, I'll leave it at that. A few other things I can do is say fastest or highest quality, high quality, production quality. This means how much of the data set, how much are we going to use to train the models. I'm going to do fastest for now, but before I go to production, I would choose production quality. And also don't forget, if you are a little more familiar with data science, you can affect the prediction threshold. We can do automatic retraining on a daily, weekly, or monthly basis. And then we can also do white labeling. So I'm not going to bother with that today, but we can make this look, take the Akkio badge away and white label this for you as well. So I'm going to hit predict. It says it's going to take a minute. It should not take a full minute to happen because I've kind of done this before. But what you're seeing it do now is take 80% of the rows. I had 1,400 rows in there, so it's taking 80% of those. And it's going to apply what should be about 1,100 rows or something like that. It's going to train those against every one of the models. You can see which ones it's training against. And then it's going to take the 20% after it's trained the models and test each one of the models in the back end. Normally, I would be building this model myself, probably picking a model to run it against. I have a few that I've saved over the years, but still running it. And then I would be determining which is the best one. This is going to tell us automatically, and we'll expose that to you as well. We generate an insights report that you can then share. So you have complete confidence in the model that it chose, and you know why we chose that model. So there we go. Attrition, yes, is the outcome we're looking for. It's important to note that I could be looking for attrition of no, but I want to say who is likely to attrit. Now it says a 90% accuracy, but that's 266 out of 293 rows were classified correctly. It's 5.3 better than the baseline, but if I hit accuracy details, we do something that is commonly referred to as a confusion matrix. We use a little bit different layout. It's called a matrix because normally it's in a 4-square matrix. In this case, we do it a little bit differently. And I'll point out here, true negatives, 98%, nailed it. We are confident employees that are not likely to leave. Remember, we do that 80-20 split. 80% we trained, 20% we tested. Out of that 20%, we found that we were right about people who weren't leaving 98% of the time. That's awesome. You're not going to focus on those employees. You're saving your efforts because they're not likely to leave. But if you look up here, I said 90% accuracy. So you could be fooled by that a little bit, but the ones that were likely to leave, 51%. Now I could do subtraction and say, well, if they weren't in this group, they're going to fall in that group. That's fine. But we could probably improve this a little bit. So there's still a little bit of work I would do on the data and do some feature engineering maybe to take a look at it. Maybe ignore some more rows after we do some more analysis. Now, if you are a little more familiar with data science, you'll be familiar with precision recall F1 score. We provide that to you. Also, we show advanced model details. So we see exactly which model we chose, multi-layer neural network. In this case, when do we train it? And then we kind of show you the loss graph as well if you wanted to dive into that. For our sake now, what I'm going to go to is top fields. Again, this is more insights. We already did some insights with Chat Data Prep and Explore, but if now we're looking at, wait a minute, job level is the highest factor of when they're likely to leave. Impact on yes. If they're at level 1, their lowest level, they're 7% more likely to leave. That makes total sense. They're entry level. They're likely to leave. Maybe it's not the job for them. Maybe they're unhappy. Maybe they don't like the company. I don't know. They're right out of college, that sort of thing. But as it moves up, you can see it goes down. That makes total sense. Overtime, yes or no? If they worked overtime, 10% contribution to them leaving. This makes me think typically overtime I would think of as a voluntary. In this case, it might be mandatory overtime. Maybe they're being overworked and it depends on what role they're in. Maybe those people in job level 1 are also being asked to work overtime. The way I would explore that is I would go back to my table, go to Explore and say, hey, show me the correlation between job level and overtime. And it would give me a chart that tells me how many people are in overtime and at what job level, 1, 2, 3, and 4. And I could see that very quickly. So again, without even leaving the platform, I can kind of draw these correlations if I wanted to. Number of companies worked, again, as it goes up. So 3, it has a negative impact. If they worked 5, it has a positive impact. 6 makes total sense. They're an individual who likes to switch jobs for one reason or another. They might be in the field that they like to switch jobs. And if you look, sorry for the sales representatives that are watching this, but when you're in sales, you have a tendency to switch jobs a little more often. That's how it goes, nature of that type of role, in my experience. Top factors as well, we'll tell you how the actual top factors, years at company between 0 and 2, what the impact is on the actual predicted column that you wanted. Overtime is yes. Again, we're seeing that correlation there. And then also we segment your data. I mentioned this before. We talked about Martin and getting those contributions to the campaign, but likely yes to attrit. What makes up somebody who's likely to yes to attrit? Work-life balance is 1, very low work-life balance. Makes sense. Job roles, human resources. That's interesting. Number of company worked 5. We saw that earlier. Education field is marketing. That's a big contributor. Interesting. Okay, that might be something at this company from this data set. Now, unlikely, job levels 5. Makes sense. Research director, unlikely to leave. They're a higher level job. I can tell by the word director typically. They don't travel. Makes sense. So we segment the groups and you can tell, well, the people who are unlikely to leave fall into these categories typically. The people who are likely to leave fall into these categories. Here are the people in the middle. You use that segmentation against your data set to make some decisions and kind of group your different rows or the different, in this case, employees into different groups and see how that might apply. We also provide a decision threshold graph that allows you to kind of segment and see which group falls into which segment, likely, unlikely, certain, that sort of thing. We see how they compare against the base rate and what the group size is just by moving the sliders. That gives us some analysis as well. And then, of course, some sample rows at the bottom. Now, the final thing we need to do is make this available to the business. So if I hit the plus button, we have a few ways of doing that. I said the API, I can deploy that. Click of a button. Click. And here we go. I'm just going to use the top fields here. That's what's selected. And it says here's a curl command that will let me do what I want to do. Here's a sample data set that or a sample employee that I'm sending in, and here's the response. If you look down here, we tell you probability that they're not going to attrit is 30. Probability they are, 69. This one's likely to attrit. So that's an example of an API call. Your developers will take advantage of this and they'll run with it, no problem. I can do another deployment though, called the web app. And this one, I'm just going to leave again the top fields here. But I could select more fields if I want to put age or something like that in there. I could just by clicking it. You see it just appears. And this will create a web app. This is what it looks like on your phone. This is what it looks like on your web browser. I'll hit update deployment. I hit update because I've done this before. And if I do web app, I'll go to live app. And it literally allows me to type this in. So distance from home, 22. Satisfaction, I'll put 3. Job involvement, 2. Job level, I'll do 2 because I know 1's really bad, so I don't want to do that for you. Research scientist, maybe. I didn't look at that one. Job satisfaction, I'll say 2. Let me maybe do a 2.5, something like that. Number of companies worked, 3 seems in the middle there. Overtime, no, because I don't want to skew it too much. Relationship satisfaction, we'll do that. I won't put them all in, but we'll hit predict. Now you would normally do this, you could do it one by one, but you could also upload an Excel with all of your employees into this web page right now, and it'll download back to you an Excel or CSV or whatever you want of all those employees ranked. It'll add 3 columns to it: attrition, yes or no, and our probability no, and our probability yes. So you would leave the attrition field blank. If you're not sure what that data set should look like, you can always click this and we'll tell you what columns we expect, and we'll actually give you an example CSV if you really want to do that. Again, you can integrate this with our API, so you don't have to do this manually. But that's how you can get predictions in the hands of the business. So just to recap, what we did was we uploaded our data, we manipulated the data, we cleaned it, we created a couple other fields, we removed some rows, that sort of thing. Then we went through and we created some pretty cool reports. Well, a couple of reports, they're not the best, but I did some pretty neat stuff where I asked it, hey, what should I be looking at this data? It told me what to look at, and I explored. I should have spent more time on that if this was really what I was doing for my work. Once we got the data the way we wanted it, we came to predict, and we created a model. We said, hey, this is good enough. We think there's some stuff we could work on with identifying the people that are likely to leave, but we could work on that in the future, maybe ignoring some more fields, that sort of thing. Then we deployed our API, and we deployed our web app. Really quick in front of you. We do this all in about 10-15 minutes. This entire thing took about 25-30 minutes to go through. But this is the power of Akkio. Can you do this on your own? Sure. I've done it hundreds of times. It takes months. You have to pay somebody like me, a data scientist that knows the data, and somebody from the business that knows the business outcome. Now we're taking it and we're putting it in the hands of anyone who's watching this video and say, hey, can you upload the data? Do you understand what the fields mean for the most part? If you don't, we can help you with that. I showed you that with Explore. And then can you train a model? Sure. You hit go and start making predictions. Now, we always want to compare this against what we think the real world would be. And a good way to test is I could take that original data set that I had up here, and I could drop it right on this page, removing the attrition column, just blanking it out in Excel, seeing how it does, right? I could take my data from a week from now and do the same thing. So we can always do what's called back testing against the system. Akkio makes it easy. If I want to make changes to this, minutes, right? I don't have to go back to another team. I can do it myself. That's the power of Akkio. I can't wait to see you in there. Have fun.